So last lesson we started looking at linear functions and linear relationships. This lesson we're going to look at building on that, and we're going to be, rather than being given a graph, you're actually going to use the equation of a line to draw the graphs. Now, there's two different forms that you could expect to see. Gradient-intercept form, which is the form that we were looking at last lesson, where we had y equals mx plus c, where m gives us the gradient or the slope of the line, and c shows us the y-intercept. And remember, the slope is always given by the y step over the x step. So we'll start off with this first example, and they would like us to draw the graph of y equals 3 over 2x minus 4. So remember, the value here, when the graph is in y-intercept form, this value here will tell us or indicate our y-intercept. So since this is plus c, this is essentially saying plus minus 4. Therefore, our y-intercept is going to be minus 4, not positive 4. So here's my graph, here's -1, -2, -3, and -4 is here, 5, 6. So from this, I can straight away say that my y-intercept would be minus 4, only if it's in this gradient-intercept form. Now, using this, we also know that the gradient is given by the y-step over the x-step. So we know that the y-step is 3 and the x-step is 2. What does that mean? It means that we come across 2 units in our x direction, and then we come up 3 units in the y direction. So using our slope, our x-step, 1, 2. So this is our x-step, 2 across, and then our y-step we can see is 3 up. So then we'll have to come 1, 2, 3 up. So we can use that point. Since we now have 2 points, we connect them to draw the equation of the line. So we could draw our line through here. Remember to put arrows on either end of the graph to show that it's continuous. You can write the equation of the line next to it. Y is equal to 3 over 2x minus 4. Remember, this here was our x step, and this here is our y step. So whenever you're trying to draw a graph, if the equation is given in gradient-intercept form, start off by using the y-intercept by plotting that point on your Cartesian plane, and then you can use your slope, the x-step, so the y-step and the x-step, to find another point, and then basically you just draw your line between those 2 points to form the equation of the line. Now the other type of form that we might see is what we call general form, where you can see we have both the x and the y are now on the same side of the equation. Now, if you ever were to be given an equation in this form, the value in front of the x does not tell you your slope, and the c value does not tell you your y-intercept. So we can only use that if the graph is given in gradient-intercept form. So in this situation, so you can see that they've given us an equation of some graph, 3x plus 5y equals 15. So you could not say that this is the y-intercept and that's the slope, because it's not in the correct form. But we have another method that we can use to do this. So basically, to draw any graph ever, if we know where 2 points are on that graph, we can plot them and then we can join the 2 up to form the equation. Now, a little trick we can use is we can basically substitute values into our equation, and once we substitute values into our equation, we can find values that can be plotted. So if we want to find the y-intercept, basically we know that the y-intercept always will occur when our x value is equal to 0, and our x-intercept will occur when our y value is equal to 0. So if I substitute the value of x is equal to 0 into this equation to find a value for y, I can use this information to plot a point on the graph. So when x equals 0, so when x equals 0, we know that that's going to be the y-intercept. Remember, whenever x is equal to 0, we have the y-intercept. So if I substitute x equals 0 into this equation, I'm going to have 3 by 0 plus 5y is equal to 15. Now 3 times 0 is just 0, so I'm just going to be left with 5y is equal to 15. And then if I want to get the y all by itself, I just need to divide both sides by 5. So dividing both sides by 5, I'll just be left with y is equal to 3. So I've determined the point. I know that when x is equal to 0, y is equal to 3. So when x is equal to 0, y is equal to 1, 2, 3. So I'd be able to plot that point. So just let me finish putting these in. So my y-intercept is 3, and that's when x is equal to 0. Now, one point isn't enough for me to draw the graph, so I need one other point. So if I say when y equals to 0, when y is equal to 0, I can determine the x-intercept of the graph. So if I substitute y is equal to 0 into this equation, I'm going to have 3x plus 5 by 0 is equal to 15. Now, 5 times 0 is just going to be 0, so I'm left with 3x is equal to 15. And then if I want to isolate the x, all I'd have to do is divide both sides by 3, so I'd be left with x is equal to 5. So therefore, when y is equal to 0, my x value is 5. So now I have 2 points. I have my point 0, 3. That's the coordinate 0, 3. And this is coordinate 5, 0. So since I have those 2 points, I can now join them together to form this equation, this line. And again, make sure that you write your equation of the line next to it. So I might write down here 3x plus 5y is equal to 15. So we've just gone through 2 different ways of plotting graphs. If you're given Y-intercept form, remember you first use your gradient intercept form, you first use your Y-intercept, which is given by the C value, and then you can use your slope to show the Y step over the X step to get a second point, and you draw a line through the 2 points to draw the graph. Or if we're given an equation in general form, then we can find the x-intercept and y-intercepts by saying when x is equal to 0 and when y is equal to 0, and we can use those 2 points to draw our graph. So now I'd just like you to work through the following questions listed on sector, and there's a range of both y-intercept form questions as well as gradient intercept form questions.